Okay, hello, welcome to my channel. Now in this video we want to treat double integrals, all right, and the examples we'll be considering will demand us to interchange the integrals, all right. So some integrals could be really hard to evaluate and we can't just do them inside out, so trying to interchange, okay, could be easier for us. So in fact that's exactly what we are going to be doing, right? So just stay right into it and don't forget to subscribe to my channel, share this video with your friends, and you'll enjoy the video. Okay, so let's just get right into it. Okay, so as you can see, this is a double integral here. Okay, this is the integral from square root of x to 1 of cosine of y to the third power dy. So if you want to integrate this the way we did in our last video, okay, where we just integrated it inside out, you see that we are going to have to integrate cosine of y to the third power dy. Well, unfortunately, this does not have an elementary solution, right? So it will be way more difficult, right, or even impossible. So one way of doing this, okay, since we're having a double integral, is by interchanging the integrals. That is to say, we interchange the x and y and also the bounds. But we're not just going to be doing that just like that, because this right here is a function of x, all right? So we will have to be careful, and we are going to visualize this on a curve, right? Just plot the graph to see how it looks like. Not really a perfect kind of graph, but we just want to see what we are doing, right? So we notice that this is dx, the outside one, so this is the integral for it. It goes from 0 to 1, right? So we pick 1 here. Okay, and then y goes from the square root of x. So y, the lower bound, is a function of x, which is square root of x. It goes from square root of x all the way to 1. So let's take y to be 1 here, right? And it's perfect because since this is a curve for y equals to the square root of x, you notice that when y is 1, x has to be 1 as well, right? Okay, that's nice. Well, let's see. So what do we now get from here? Well, notice that x goes from 0 to 1, okay, while y goes from square root of x to 1, from square root of x all the way to 1. So in fact, this is the area we are considering, all right? So you be careful when we are looking at dy first, okay, before dx, okay. The area will always have something to do with here, all right, and not this part, so be careful with that. Then we want to look at, let's say, an arbitrary rectangle, okay, and we want to look at it horizontally. The reason is, as it is this way, okay, we'll be considering them vertically, that is dy first before dx. So to be able to interchange this, we want to look at it horizontally before vertically, and that will have to do with observing where this changes, okay, how this changes. Well, we will know that y changes from 0 to 1, while x changes from 0 to this curve, right? It now depends on this curve. So here we want to make x object of formula. We'll have x to be y squared. So let's see what we have from there. Well, this integral will now become the integral and the integral. So this is what we want. We want to interchange dy and dx. So this is dx, and then we put the dy here, all right? Well, of what? We'll put the original function. Always put down the original function and interchange as you want. It is the bounds that would decide. Okay, so you notice that y changes from 0 to 1, okay, so y does not have problem, so y is the outside one, so we're going to write y from 0 to 1, okay. That's nice. Then we will consider x. Well, x changes from what to what? Like I said, x changes from 0, which is the this line here, all right, that is the line for x equals to 0, to it's now bounded by this curve, right? That is, it has to do with this curve. So from 0 to what? Well, we make this subject of formula is going to be from 0 to y squared, okay. All right, so that is how to interchange those two integrals, and then from there we're going to equate these two. Well, let's see. This is going to be the integral from 0 to 1, all right, while this is the integral. Well, let me put it up here so that you see. Okay, so this is going to become, well, let's put the integral from 0 to 1 here. Then, well, we are now going to integrate this function here with respect to x, and it's really easy to do that, right? Because this right here is a function of y only. So integrating it with respect to x, we are going to regard this as a constant. So that means we are going to multiply it by x, okay, and then we put down the original thing, which is cosine of y to the third power, and then we put the dy here. Okay, let me not put the dy first. We will put the bounds of integration. So this is integrated from where to where? Well, from 0 to y to the second power, right? Okay, so we are going to integrate that to see what we have. Well, you notice that 0 to y squared is value for x, okay? So when we substitute y squared in place of x here, we're going to have just y squared, right? And then we are going to substitute 0. Well, everything will be 0, so we just consider y squared times the cosine of y to the third power, and then we will put the dy over here. Okay, that's nice. Now we are now ready to integrate from 0 to 1 of this function with respect to y, and it is easier than it was before because we have something here to help us. So you notice that here we can just do a u sub. We say let u be y to the third power, right? So this is y to the power 3. When we do that, you notice that the derivative is going to be 3y squared. Well, we just have y squared here. Notice that if we multiply this by 3, we are going to have 3y squared, right? But we need to balance that product by dividing it by 3 again. Okay, so we've just done multiplication by 1. So you notice that this is going to be 1/3, okay, of, well, when we integrate cosine of y to the third power, given that we have 3y squared here to help us, that will just give us sine of y to the third power, right? The integral of cosine is just positive sine, okay? And then if we do a u sub here, you are going to see that that will work, and then we are going to take this from 0 to 1. Okay, so let's see. This is 1/3 of, well, when y is 1, we have sine of 1, right? That will just be sine of 1. And then we substitute 0. Well, sine of 0 is just going to be 0. So this right here is the result, right? Okay, so this is it for this one. And let's go over to another example. Okay, so here we have another example. We have the integral from y to 1 of 1 over 1 plus x to the power 4 dx, okay? And then the integral from 0 to 1 of the whole of this dy. Okay, so notice that if we want to start this from inside out, okay, we are going to have to integrate the whole of that. But this is really hard integral, right? It takes a lot of time. So let's try to interchange and see what we have. So to interchange, we will have to start off by drawing something. Okay, represent this on a curve to see what's really going on there. So, okay, so we notice that dy changes from the y, okay, changes from 0 to 1. So this is 0 on the origin, and then let's call this 1. While x changes from y to 1. So we are going to draw the curve y equals to x. Okay, since x changes from y to 1, notice that is just the identity function. That is just going to be a straight line, right? Okay, and then x changes from y to 1. So it's going to be from y to 1. And notice that since this is a curve for y equals to x, okay, it is just going to be a straight line, and when x is 1, y is going to be 1. So that works, right? Well, dx is here, so yeah, we are going to have we are going to be considering this region, right? So we want to interchange this, so we will not be considering the horizontal rectangles, rather we'll be considering vertical rectangles. So this is how we're going to maybe show an arbitrary rectangle. I'm going to show it this way, okay, something like this. So you notice that this right here changes, the y changes, right, with respect to this curve. So that means to interchange this, we are going to consider this is going to be the integral. Well, the way we used to put integral, right? Integral, then you want to interchange it as dy and dx instead of dx dy dx. So what will y change? Okay, let's start with the x. Okay, x changes from 0 to 1, right? You want to look at each of these rectangles to just change from 0 to 1, okay? The x axis. for the curve, right, or for the region, while the y changes from 0 to this curve. So this curve now decides for us. So we now say y changes from 0 to what? Well, this curve is y equals to x, so we say y changes from 0 to x. All right, and then we are going to put the original function, which is 1 plus x to the 4th power. Okay, so now you notice that here we'll be considering this is 1 over 1 plus x to the power 4. We to integrate this with respect to y. So in fact, this right here will be regarded as a constant, since we are integrating with respect to y. All right, so this is going to be the integral from 0 to 1, okay, of when we integrate this, we just have to multiply with y. All right, so that is going to be 1 over, let me bring this down a little bit. So this is the integral from 0 to 1 of 1 over, let me put the original thing, 1 plus x to the power 4. Then we multiply it by y, that is after integrating, and then we have to evaluate it from 0 to x, okay, and then you put the dx over here. Okay, that's nice. So let's see, when we substitute x for y here, we're going to have integral from 0 to 1 of, substitute x here, we're going to have x, right, divided by 1 plus x to the power 4. Then when we substitute 0, notice this is going to be 0 times everything here will just be 0. So in fact, we just put the dx over here. So we have this function to integrate. In fact, this function is a lot easier than the first, right? And the reason is, well, we are going to rewrite the integrand a little bit, and you're going to see this is integral from 0 to 1 of, well, let me put the x over here. Now I'm going to write x to the power 4 as x squared, and then I will square it. Okay, so you notice that if you make a use of, we say let u be x squared, right, this inside here, x squared, then the derivative will just give us 2x, right? So let me balance it by dividing it by the 2, which I just multiplied. So all in all, what we will enter with is 1/2 of, well, this is u, okay, let me just show you what I mean. We say let u be x squared, then du will be 2x dx, right? So here is u, then 2x dx will become du, so we'll be having integral of du divided by 1 plus u, and then u has been squared, you square that. So this is in fact inverse tangent, okay, of u. And what is u? U is said to be x squared, so that is inverse tangent of x squared, and we have to evaluate that from 0 to 1, right? So you keep that. All right, so what will this be? Well, let's just do that real quick here. I think that's okay, so let's just do that real quick here. When we substitute 1, you notice that is x squared. Inverse tangent of 1 will just give us pi over 4. So yeah, pi over 4, you know, tangent of pi over 4 will give us 1. So inverse tangent of 1 will be pi over 4. Pi over 4 times 1 over 2 will just be pi over 8. Now notice that when we substitute 0, inverse tangent of 0 will just be 0. So yeah, this right here is the result, right? Okay, so that is it. Those are the few examples, okay, that we're going to consider in this video. And if you enjoyed the video, please, thanks for watching. Subscribe to my channel, and stick around, okay, and enjoy more of my videos.